Hi guys, so today we will be solving one interesting question. The question is based on window sliding techniques. So the question is, we have given an array of size n and an integer k. Find the maximum for each and every contiguous subarray of size k. The question, we have given an array and we have to find a maximum of element of given contiguous subarray of size k. Yeah, so answer will be in a vector format. So this is all about the question. So let's move on the solution part. So I have written already, this is array having element 1 2 3 4 5 2 3 6. Let's say the window size k is 3. Okay, so this is a window size 1 2 3 and we have to find the maximum element in every windows. So this is in this window we can easily see the maximum element between these three is 3. Now move this window next. Now this window the maximum element is 4. We can see easily 2 3 4 and similarly when move next, move this, and in this window the maximum element is 5, and again the move next. So in this window is in this window the next similar maximum element is 5. Now this window also the maximum element is 5. Similarly in this window the maximum element is 6. Okay, so this is the answer we have to return. So for solving this question we have two approach. So one is a brute force approach. It's like we have given an array. So let's say I will copy this array. Okay, let's paste here. Okay, yeah. So the first approach is brute force approach. So in brute force approach what we'll be going to do, so we have the array. Okay, so we will be first apply a for loop from 0 to n minus k minus 1. So here we have taken k equal to 3. Okay, and the n is here what 1 2 3 4 5 6 7 8. Okay, so 8 minus 3 5 plus 1 6. So we will first outside for loop will be run till here. Okay, the 6th element, and the inside the loop we will be run from for j equal to I to I plus k, and then we will find the maximum element and just push this value in any vector, answer vector, or here I have taken temp. So similarly, so let's explain this, the brute force approach. Let's say this first piece, this is a outside, this is a I. Okay, I is here at 0 index. Okay, so inside this loop the j will be run from 0 to 3 because 3 plus 0, so 3. Okay, and inside this 0 to 3. Okay, so 0 to 3 this is. Okay, and we have find the maximum element, that is maxi, we will be find it using this loop is, it will be 3, and then push this element value in temp. Similarly when I will be moved to here, then we will be shift to this window. Okay, this window, and this window the maximum element will be 2 3 4, the maximum element will be 4. Similarly here maximum element will be 4, so we will push this value in temp. Similarly when we move in this window, when j will be vary, when I will be come here, so j will be vary from I to I plus k. So this will be I and I plus k is 3. So this will be, in this window the maximum element will be 5. Similarly, when move to this, the 4 5 2, this maximum will be 5. When the move with this, maximum will be 5, and when move to this, the maximum will be 6. So we can check the answer. This value and this value will both will be same. So this is a brute force approach. The time complexity of this approach is big O of n square, because this is approximately n. This loop will be run n loop, and this will be approximately k. So n into k. So we can say it's a big O of n square. This is a time complexity of first approach. So how to optimize this code or solution? So we will be going to use window sliding technique. Okay, so in window sliding techniques we will be using one data structures, dq. So dq, in dq we can push the element from front and back also, and we can pop the element from front and back also. Okay, so this is a bidirectional. So in this approach, what we will be going to do? So first we will be make one dq. Okay, let's say this is a dq. Okay, and one answer will be, okay, this is a vector. So in dq we will be not store the element, we will be instead of storing this element, we will be stored index of that element. Okay, so first what will be going to do? First we will use for loop from I0 to k. Here window size is k equal to, let's say, 3. Okay, so window size is k equal to 0 to 3. First we will be using. Okay, so first push this element. Okay, so what will be the element is push this element. Okay, now when we go move and want to push the second element, we will be check if, here we will be first check if, sorry, inside this loop we will be using while loop. Okay, and we will be check like if, like is a array. Okay, so array of I is greater than array of, okay, this is here, array of dq dot back by, if this is dq dot back, then what we will be going to do, we will be simply, we will be pop this element and they push the larger element too. Okay, similarly this sorry, here we will be not storing element, we will be here store the index. So the index of this is 0 and index of this second one is 2. So this will be already pop back. Okay, now again we check that array of 2 value is greater than the array of this array of 1. So this is greater than, so what will we going to do? Just pop back. Okay, so this is the 3, this is the size of window 3. So okay, then 3, after traversing 3, we will be store the front element. This is the front element of dq. So just to take the pop here, and again now we will be using next for loop from j, that is equal to k to less than n. Okay, So now what we will be going to check here, one more condition we will be apply. Okay, so if here we will be apply, let's say like here we will be use a condition if, okay, so let's use this. Okay, so what we'll be going to use here, so if dq dot front is less than equal to j minus k, then what we will be going to do, if this condition will be followed, then we will be pop front element. So why we will be doing this? This is a general question. Yeah, so why? So let's say this is array. Okay, let's say I have taken another array. Okay, so let's say this is array is 3 2 1 4 1 and 4. Okay, and 5. Let's say this is okay. The index of this is 0 1 2 3 and 4. So what will be go and here we will be using window size 3. Okay, so what is the approach? Our approach is, so first we will be run the loop from 0 to k. So k is 3, so we will be using this loop. So okay, and what we will be going to do, so first store the index of this value, so 0, and now we will be going to check that if array of this front element is less than equal to this array of I, then what we will going to do, just pop this element. Okay, but here the 3 is greater than 2, so we will be not pop this element. Okay, so simply this value will be stored here. So, okay, 2. Now if check 1, simply 1. Okay, so now 1 is less than 2, so we will simply push back this dq. Okay, so now this first for loop is completed. Okay, now in second round what we will be going to do, so we will be run the loop from j equal to k to j less than n. So here from j equal to k. Okay, so what, and we will be, let's say and what will we going to do, in answer we will be store the front element. Okay, front element. Now if now in the second window, this is the second window. Okay, so we have to check that if this front element, because we will be not consider this element in our second window. Okay, so we have to check that if this front element is less than or equal to j minus k. Let's say this is here the j value is 3 and the window is 3. Okay, so index is 0. So if index is 0, this is the index is 0, so we have to pop this element, because we are not consider this 0 index in second window. Understood? So that's why we will be using this condition. Okay, and then second we will be simply use the first first condition, like the condition we have used initially in the first for loop. Okay, so simply the second condition is similarly like that. If array of I is greater than array of dq dot back, then we will be push back this element and store that the element, new element. Okay, so here we have checked that 3 sorry, here not 3 is a 2. Okay, it's a 2 because we are storing the index. Okay, so the 3 we have to store here. okay, and then move to second windows. So if we move second window, then we have similarly check that one is greater than less than 3. So just sorry, just store, because it's a less than. If greater than, then we will be remove this element or pop back this element, but this is less than, so simply store the index of this element. Now if 4 is greater than this, so what we will be going to do, just pop back this element, okay, and then 3 is also greater than 3, so this pop back this element also, and then post back this index, okay. So now we in second loop we have seen that the front element is 4, so array of 4 is 4, so we have taken 4 here, okay. Similarly we will not this is will be third round. In second round also we will be get 3 also here, 3 in this is the array of 2, so we will be use 2, and then third round we will be got 4, and similarly that we can find this, okay. So let's move on the coding part. This all is a theoretical part. Let's move on the theory coding part. So first we will be declare one vector int, let's say answer, okay, and then we will be declare one dq having size sorry, not size, in type, okay. So I have already told we will be first run for loop from I equal to 0 to I k, and then we will be check if this dq is not empty and this array of I is greater than equal to, if this array of I, this is array of I is greater than equal to array of dq dot back. Why we will be using dq dot back? Because we will be here in dq we will be storing index, not element, that's why. So just if this is, then we will pop back that element, and okay, and now we will push back the greater element, okay, not greater but index, okay. Now we will be run second for loop, okay. This will be from I equal to k equal to less than equal to n, not, no, we can use that, what the problem is, okay. I plus plus, here we first we will be post back the answer, post back the front element, okay. So array of dq dot front, and now we will be check if dq is not empty and this dq dot front is less than equal to I minus k. If it is, then we will be dq dot pop front, and then we'll be using same condition here also. Just take copy and paste and return answer, okay. So this all about code, so let's compile it. Yeah, so we got the successfully compile this. Now submit this code. Yeah, so this is successfully submitted. So this is all about this question. So thank you so much for watching this video.